So continuing on 9.1, calcium. Calcium is an important thing to have in your diet. Calcium is a vital nutrient for healthy bones and teeth. The National Institute of Health recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Is this true? We're going to perform a significance test to find out. First thing we need to do is state the hypotheses for this significance test. We should be able to do this by now, based on yesterday's amazing amount of information that we learned. What do you guys think the null hypothesis is for this problem? What is 1,300? The mean. If I'm talking about the mean of a population, that would be what notation? Mu. So, mu equals 1,300. That's what it's supposed to be. But the NIH is concerned that teenagers aren't getting enough. What is the alternative hypothesis? That mu is less than 1,300. Oh, I forgot the milligrams. My bad. All right, and again, we need to define our parameter. Mu is the true mean calcium intake for teens. All right, so that's our null and our null and alternative hypothesis. The null hypothesis is that teens are getting what they're supposed to, but the suspicion or the concern is that they're getting, in fact, less than they are supposed to. And so we're going to do this significance test. We're going to take a sample, and we're going to see what is going on here. All right?
What's up?
Do you have any questions about the null and alternative hypothesis? You feel good about this? Cool? Okay. So, the NIH takes a random sample of 20 teens and records their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that the sample mean is 1198 with a standard deviation of 411. Okay, time out. Based on that sample, are the teens getting less than 1,300 milligrams of calcium? Obviously, 1198 is less than 1,300, is it not? Okay. All right, 1198 is less than 1,300, so it seems like we should just be done, right? But no, here's the problem. Is this difference due to sampling variability, or is it actually so low of a sample, as extreme or more extreme? Is this so low of a sample that there's no way it could be sampling variability and there really is a problem going on? So we do the significance test and we get a p-value of 0.1404. Here's what that p-value means. Assuming the true mean is 1,300 milligrams of calcium, there is a 0.1404 chance. By the way, you guys know that that's 14% basically. Yeah, hopefully. All right. There is a 0.1404 chance of getting a sample as extreme or more extreme than the one we observed. So basically, guys, here's what we've got. We've got a normal distribution. I know it's normal because they're all normal. 1,300 is our mean. We took a sample and we got 1198. the probability that we get a sample that is as extreme or more extreme than that is 0.1404. That is the chance that we have gotten this sample due to sampling variability. Is that low enough that you think that teens really aren't getting the 1300? Is this too low for you to feel comfortable that this was not just sampling variability? Or do you think that this was just sampling variability? So there's a 14% chance that we get a number that is this low or lower on an actual 1300 milligram distribution. So how low, or do you think that that's too low? It depends. How low is too low? Well, we have to have something to compare it to. But for now, that is the p-value, okay? All right. And what do we compare that p-value to? We compare it to the statistical significance level. Whoops. I apologize. The final step in performing a significance test is to make a conclusion about the competing claims that we're testing. It's either going to be that the null hypothesis is the one that we're going to settle on and say, well, we don't have enough evidence to prove anything else, so we got to just go with what they say. Or do we have evidence that there really was a difference and it wasn't just sampling variability? So we're going to make one of two decisions based on the p-value. We are either going to reject the null hypothesis, or we're going to fail to reject the null hypothesis. Well, that seems weird, doesn't it? So here's the deal. You guys know about trials. I'm sure everyone's seen a movie where there was a trial at some point. When the person that's on trial, they are innocent until proven guilty, right? They have the trial, and the jury goes back, bless you, and deliberates. When they come back, what are the only two decisions that they could have given? That the person is either what or what? Guilty or not guilty. Why does the jury never come back to say, we have found this person to be innocent? Why not? Why don't they say that?
Because you're always innocent. Until proven guilty.
You're innocent until proven guilty. So the whole trial is trying to do what? It's trying to prove the person's guilty. Now, the defense is like, no, they're not guilty, I promise. This evidence that you're seeing, it's really not true. Okay, not true, okay. So, we're trying to prove that they're guilty. The jury has to make a decision based on the evidence.
What are you looking at?
You have gotten up 14 times today already.
I have to throw this away. What?
All right. The jury has to look at the evidence and say, we have enough evidence to believe beyond a shadow of a doubt that they are guilty. Or they look at the evidence and say, we have some evidence here that kind of looks like something was a little weird, but we don't have enough evidence to feel good enough to send them to jail. So we're going to say that we don't think they're guilty because we don't have enough evidence of that. That's what we're doing here, okay? The null hypothesis is true unless we can prove otherwise. We are always trying to prove the alternative. We can either reject the null hypothesis because we got enough evidence to prove the alternative. Huh?
Call it its real name.
Or we can fail to reject the null hypothesis because we didn't get enough evidence to show the alternative. Okay? But here's what we never do. Just like a jury, we never come back and say that the null hypothesis is for sure true, because we don't really know that. So you are going to never, ever, ever accept the null hypothesis. Okay? So, let's just say what's going on here. Basically, you guys, we have a hoe. And the hoe is on trial. And we're either going to reject that hoe, or we're not going to be able to reject the hoe. But we're never going to accept the hoe. Okay? Never. We don't ever accept hoes. Don't do it. Don't do it. You either have enough evidence to prove that they're really not a hoe. Ha! The alternative, right? Ha? Right? Ha! They're not a hoe. Okay, so you can reject the null hypothesis. Ha! Or you don't have enough to reject the null hypothesis, but you never, never, never accept the hoe. Okay? How do you know which one to do? It is fully based on the p-value. If the p-value is less than alpha. What is alpha? Alpha is the significance level. Alpha is the significance level. It's basically your decision point. If your p-value is lower than your alpha level, your significance level, then you're going to reject the null hypothesis. If your p-value is greater than or equal to your alpha level, then you have to fail to reject the null hypothesis. That does not mean you're accepting the null hypothesis. You're just not able to reject it. You didn't get enough evidence. Your evidence wasn't good enough. Okay? All right, so my first year teaching stats, I went to a conference where they taught teachers how to teach stats. And my teacher was a 70-year-old woman named Peggy Smeltzer. Sounds 70, right? And she was teaching us about p-values and about how to make a decision on a significance test. And she said to a class full of educators, if the p-value is low, you reject that hoe. And we were like, excuse me, ma'am, what? Huh? She told us that that is the best way to remember when you are going to reject the null hypothesis or not. If the p-value is low, lower than the significance level, that's when you get to reject the hoe, the null hypothesis. Okay? So, what are we going to do when our p-value is low?
Reject the hoe.
We're going to reject that hoe. That's right. That's absolutely right. Yes, 100%. If the p-value is not lower than the alpha, then you're going to fail to reject. But Hayden, what are you never going to do?
Never accept no hoe.
That's right. You're never going to accept a hoe.
That's right.
That's right. This is more than statistics, you guys. This is a life lesson. All right, cool. Here we go.
Base. Beta milk.
Oh my.
This lady's so sick, man.
Yes.
Sigma Andrew take Miss Lakey.
I will. I need to update Canvas today. All right, so let's look at this in terms of an actual example, actual problem. I forgot to update the name in this problem, but we'll pay homage to our Officer Trainum here. So, Officer Trainum, or whatever SRO at the time, wants to determine if it is worth the cost to install a speed sensor wants to see if it is worth the cost to install a speed sensor and traffic camera at the entrance to McKinney Boyd High School on Lake Forest. Do you guys think there's some speeding happening over there? No, never. McKinney PD will install the speed sensor if and the traffic camera if they are convinced that more than 20% of the cars are speeding in the school zone. Officer Trainum selects a random sample of 100 cars in the school zone, measures their speed, and finds that 28 of the 100 cars are in fact speeding. Time out. You guys, is 28 out of 100 more than 20%?
Yes.
Yes, it is. Does that seem like we've got a speeding problem?
Yes.
Possibly. Because was that sampling variability, or do we have a true difference? That's why we do the full significance test. The null hypothesis is that we've got 20% speeding. The suspicion is that it's more than 20% and therefore we need to get this camera, right? Or the speed sensor. The resulting p-value is 0.023. What conclusion would we draw based on these significance levels? So the first one is alpha of 0.05. That is a significance level of 5%. That's basically our decision point. Anything above that, we did not get enough evidence. Anything below that, we've got really good evidence that the true proportion is more than 20%. So our p-value equals 0.023. And how is that related to this alpha? Is that less than or greater than?
Less than.
That is less than the alpha value of 0.05. And ladies and gentlemen,
Reject the whole.
we have a p-value that is low. So what do? We are going to reject this null hypothesis. Now, there's one last part of this. It is to say why, just to make sure we are clear, there is convincing evidence that P is greater than 20%. Notice, ladies and gentlemen, that I have concluded based on the alternative hypothesis. We got convincing evidence of the alternative because we were trying to prove the alternative, and we got the evidence we needed. So, since the p-value was lower than the threshold of evidence, we rejected the null hypothesis, and we can confidently say that we have convincing evidence that the true proportion of speeding on Lake Forest is more than 20%. What's going to happen in this situation? Are we going to get the speed cameras and the sensors on this?
Yeah.
Yeah, so Officer Trainum takes this data over to McKinney PD. He says, look, we have convincing evidence that the true proportion that are speeding on Lake Forest is more than 20%. Give me my speed cameras. Give me all the things that you've promised me to get. The people that are in the budget for McKinney PD take one look at it and go, we don't have this kind of money. So what we think we should do is we should change the threshold. Put it at 1%. Change the significance level. Now alpha is 1%. And now, what is true about the p-value of 0.023? It's greater than the alpha of 0.01, the threshold for rejecting. So now, can we still reject the null hypothesis? No, now we've got to fail to reject the null hypothesis. Does that mean that the true proportion is truly 20%?
No.
Not necessarily. We're not accepting that hoe. But what this does mean is that there is not convincing evidence that P is greater than 0.2. Again, that's the alternative. Maybe at this point we got some evidence, but it wasn't good enough to compare to this threshold and get the speed sensor and the cameras. And now they don't have to buy them because they changed the threshold. This happens all the time. And now we don't get our cameras and sensors. Sad, right? Aren't you sad? Yes, ma'am.
Does it matter that the one above you did greater than 20% and this one's 0.2?
What do you mean? It should have been the same. No, it's the same because both ones are 20% or 0.2. All right, cool. By the way, you guys know State Plan Do Conclude, right? State Plan Do Conclude starts next week. This is the conclusion part of a State Plan Do Conclude. So you now know how to do the state mostly and the conclude. There it is. All right, cool.